Okay, let's look at these anomalous functions. Okay, so we saw that user-defined functions. Okay, we rewrite them in a separate M file. Okay, we can use them to write complicated functions. Okay, or simple functions. Okay, and we can use them as a subprogram in large computer programs. Okay, but sometimes where we run into situations where we have a relatively simple mathematical expression, but we have to reuse it inside one program. Okay, a simple mathematical expression, we reuse it in a one program. So if for that purpose, if we create a separate M file, is a little bit of overkill. Okay, so for those situations, MATLAB provide us a way these anomalous functions. Okay, so we don't need to write this anomalous function in a separate file. Therefore we can write an anomalous function anywhere, inside the script, inside another function, or even in the command line. Okay, syntax for animation function look like this. Okay, they have a name, even we call them anomalous function, they have a name. So the function name equal sign this at symbol. Okay, this at symbol return a function handle. We will talk about function handle later. Okay, then we have a argument list and a except single mathematical expression. Okay, so for example of an anomalous function, we can look at this one. Okay, the argument list. So we have the function name equal sign at sign argument list. This time only one argument, mathematical expression. Okay, so I will do the semicolon. Okay, now I can call this as, I will call a regular function. Okay, I can do q tab. Okay, sorry, not execute the value. No, value will pass into the function. Okay, so here it will be taken cube and I will get 8. Okay, if I only type the cube, it will show the function. Okay, cube equals function handle with value this. Okay, like I said, we will talk about function handle later. So this can contain more than one variable. Okay, for example, we can have function called so if we so here circle xy. Okay, so here call this function circle okay, I put the semicolon, no? So it will not show the answer. Let's do it. Okay, so I will do the semicolon. So if I do it without the semicolon, it will show you the answer. Okay, we will see the importance of these functions and enormous functions when we write programs later. We will see how to use them. Also, an enormous function can contain variables that are already defined. Okay, so for example, if I define a to be 1, b to be 2, and c to be 4, I can now define an enormous function. Let's just simply call it q equal to one variable x. This x is only the variable. Okay, here a, b, c are constant, so I can go a square, a star square c. Okay, so here I am not planning to use matrices, so I just use the regular operations. Okay, now I plugging in q. For example 0, I should get the value of c, no, 4. Okay, see, so we can use it like that. Okay, another thing, important thing, when you define an enormous function, is capture the values of the variables, predefined variables. Therefore, you can, if you reassign, you have to assign a variable, you have to want to capture that value, you have to rewrite the enormous function. Okay, for example, let's say I make c 100. Now c is 100, and I do q0. I'm getting 4. Okay, that is because previous value is binded to this enormous function. Okay, if I want c to be 100, I have to redefine the enormous function. Now if I do q0, I will get 100. Okay, so that's something important to remember when you are using an enormous function.